All right, here is a probability problem based on a random variable, continuation from random variables 6.1. We're looking at the American roulette wheel. This is from our textbook. And there are a total of 38 slots on this wheel. So imagine a wheel, and on the edge it has all these little slots where a ball can fall into if I spin a ball. It's hard to describe without actually seeing it, but feel free to look one up. But hit pause and read through it. All right, so there are a total of 38 spots the ball can fall into. And there are numbers 1 through 36, half of them are red. So that means there are 18 red and 18 black. And then there are 2 other spots that are green. So that's what we're going off of. We're putting $1 down on red, which means if it lands on red, they're going to give me $1 and another $1. I'll win $1. And then if it lands on something other than red, they'll keep my $1. So I'll come out -1. So I need to make a table and by the way, the subject of interest is right here. This is the definition of our random variable. So at first, up there in the paragraph, it's just describing a chance event. And then when they throw X into the mix, the part that I circled, that means we're looking at a random variable. So they describe this as a net gain, like how much money do I earn? So if it doesn't land on red, I'm going to lose my $1. If it does land on red, they're going to hand me back my $1 and another $1, so I come out with $1 in addition to my original $1. So people mess up there and they like to write 2, but really it's just 1. So because it's how much money I made, how much money I won. The -1 is any time the ball falls on black or green. The +1 is any time it falls on red. So use those totals that we wrote above, and that can be your probability. So green or black would be 20 out of 38, and red would be 18 out of 38, and naturally, to check your work, those add up to 1.0. At the bottom, it says, what is the average gain? They could have said, what is the expected gain? Or what is the mean gain? But either way, I'm going to skim through my formula chart, and I want to find this formula right here. So all that means is you take each x, multiply by its probability, and add. So I'm going to go -1 times 20/38 plus, now the next one, 1 times 18/38. That gives me -2/38. But we're talking about money, so let's say -5 cents. I think at the bottom of the screen it says to interpret what we just found. So remember, this is an average. On average, we expect to lose 5 cents, and here's the key to the interpretation, per game. So let's say I go play 1,000 times in Las Vegas. How much do I expect to be in the negative or positive? It's going to be negative. 1,000 times 5 cents. So be careful with that interpretation. Each game, on average, it'll come out to a 5-cent loss. All right, let's change gears. We're going to talk about standard deviation. Whoops. So we have, oh, there it is. I thought we were missing a part. So there it all is. So we can also get the standard deviation of a random variable, of a discrete random variable. And I think on the handout, this is all typed for you. So remember, variance is sigma squared, and then we're going to take the summation of x minus the mean, and the mean being what we just found in the previous problem, square it, and multiply by its probability. If we don't square, we're going to end up with 0, so that's why we want to make sure we square it. All right. Oh, and standard deviation would naturally just be the square root of that. So let's practice it with the APGAR problem that we had yesterday. Yesterday we found the mean, or the expected value, to be 8.128. So if you look up above, here's our variance formula. I realize that is a lot to type, but it's good practice. So I strongly recommend that you practice this at home. So I'm going to find the variance by going 0 minus the mean, square it, and then multiply by 0's probability. Let's try another one. 1 minus the mean, square it, times 1's probability. Maybe one more. You don't have to, at this point I would say you could do the ... and then write the 10. But let's do one more just for the sake of practice. So 2 minus the mean times 2's probability. And then let's do the ... I think we got it down. All right. In class, it was a good example because I actually had a typo. I need to change calculators. I was typing all this in earlier, and I noticed sometimes the button doesn't push. But the good news is, if this was the AP test and I wrote down everything that I just wrote up there, and if I type it in wrong, they're going to give me full credit. I'll give you full credit on my test. So please show your work. When you type it in, you should get something like that. And then we want to square root it. And we get that standard deviation. There's our standard deviation. All that work for that one number. So it does ask you to interpret. This is a form of an average, remember. On average, APGAR scores are typically within 1.4372 of the mean. All right, I hope that made sense. I'm going to scroll to the next because we went a little further in class today. And we talked about continuous random variables. So remember, a continuous variable, this is a form of measurement. So whether I'm using a ruler, a stopwatch, whatever, I'm measuring something instead of counting. I'm not counting through possible responses. And then if I graph it, it makes what we would call a density curve. I think we've talked about this before. Like, for example, the bell curve is a density curve. Down here at the bottom of the page, it talks about straight line curves, if you can call that curving, but it's called a uniform distribution, which looks like a flat line. You could have other linear things, so that's uniform. But you could have other functions. I mentioned piecewise. What if it's uniform for a little bit, and then it increases? Who knows what it does? Maybe it goes down from there. But if they want an interval of, say, this, that range, it's a little annoying because you got to get creative with your geometry. Over here, very easy. If I want that interval and that probability, that's just a rectangle, base times height. This one, I don't know what shape that is, but we can partition it off. We got a rectangle, we got a trapezoid, and another trapezoid, and we can add up those three areas to be the total probability. So we'll work with that down the road. We're going to look at a uniform distribution. We have a random number generator outputting uniformly. So when it says that, you can be confident that it is a flat line. So I draw quadrant 1 and a flat line. It is, and by the way, I don't like to make my line touch the y-axis, so I just kind of draw it floating outwards. And this next part bugs people, because this one goes over an interval of 0 to 1, so I'm going to put a 0 right here and a 1 right here. They tell us the height, but they didn't have to. We could have figured it out. Because remember, the area of the entire curve has to be 1, right? So if the area is 1, and it's also a rectangle, I know the base is 1, the area is 1, the height had to be 1. Okay, let's answer this final question. 0.3 to x to 0.7. Let's make some marks on here. So we have a nice, easy rectangle to work with. That looks like it has a width or a base of 0.4. It has a height of 1, which means the answer is 0.4. Very simple. By the way, you might write on the previous slide when it starts talking about continuous variables, for discrete variables, the or equals, you know, if I write less than or greater than or equals, does matter. We saw that yesterday with the APGAR scores when it said probability of 7 or greater APGAR score. And if we're looking at a continuous, it does not matter. We talked about this beginning of the year. Remember, the difference is insignificant, and honestly, to find probability, we need a width, because I have to be able to find it over an interval. Does not matter. So down at the bottom of the page here, it didn't matter if I wrote or equals or not. I could have put these lines under it or left them off. Same exact answer, because it's an interval of 0.3 to 0.7. Okay, that's it. See y'all later.